So welcome back to VTU e-Shikshana program on computer-aided engineering drawing. So far we have worked out problems on the planes which are resting on the edge on HP, okay, or VP, edge on HP or edge on VP. Now let us consider the problems which are resting on corner. Normally triangle, square, pentagon, hexagon, these are the planes which are going to have this type of problems. Rectangle, normally you never get such problems because longer edge and smaller edge, and also very rarely you get such problems. A typical problems will be there. Now let us take the laminate one by one and discuss. This is triangular laminate. I have a corner and these are sides, and this is the median. Normally this is one of the factor which is to be considered in engineering graphics. For any inclination they may give this, not necessarily the edge, okay. Sometimes diagonal will be given, or median will be given, or perpendicular bisector of a pentagon. Now this is median and this is the triangular lamina, and similarly we have pentagon. This is the perpendicular bisector of the pentagon. These are corners and sides, you know. And in case of hexagon, we have diagonals. One of the diagonal is inclined at some degree to HP and some degree to VP they may give. So that's why I am familiarizing with this type of planes and the corresponding items. Now the most familiar and very important thing is square lamina. So this is the diagonal. AC is a diagonal, another BD is a diagonal. So AC, A is on the ground and AC is inclined at some degree to HP. Or lamina assumes 45 degree to HP, means AC also assumes 45 degree, like that. So the thing is, you have to have the correct information and from the question, and then post it properly, try to realize and start working. It is corner on ground. Normally corner on ground refers to the corner on HP. Ground is referred to as HP. In third angle projection used to say ground. Here it is HP particularly. Now I will have a simple position of lamina. Square lamina has a corner on HP. You have to keep it like this only. So for example, this line is perpendicular to VP, say. You have to keep that edge, keep the corner on that line which is perpendicular to VP, so that if you tilt it, give inclination only to HP, the two sides, these are the two sides which are going to make equal inclination with HP. Sometimes they add that condition also. You don't worry about that. Automatically you will get that condition. See, in this case, these two sides are making equal inclination with HP. So automatically you will get. When you get this, see, in case of square, the diagonal is parallel to VP in corner condition. Then only you will get this condition. And also the surface inclined to only one plane. Suppose that I will keep it like that at random. The diagonal is inclined to some plane to VP. Okay, now you keep it like this. Then you never get these two sides equally inclined to HP. That is the necessity condition for planes problems. First, for square, diagonal is parallel to VP. For hexagon also same thing. Diagonal is the diagonal passing through the corner to be placed on HP is always parallel to VP. Then only you will get that condition, corner condition. Then in case of odd number of sides, say this is pentagon. In case of pentagon also, see these two are making equal inclination with a perpendicular line to VP. If you draw, if you tilt this, give inclination only to HP, the two sides, these two AB and AE, are going to make same inclination with VP. After giving inclination to VP also, you are going to get same inclination with respect to HP. So here with respect to VP and HP same inclination, but here only with respect to HP, but with respect to VP it will changes. Now what are the parameters they give? See, first lamina inclination to HP they will give. Next, the perpendicular bisector is inclined at some degree to VP, they will give, or the top edge, this is the top edge. See, when it is possible, when these two makes equal inclination, the lamina is inclined to HP and this becomes top edge. Okay. In case of the hexagon and square, top corner, see here is a top corner is some height. Instead of giving inclination, they may give top corner, just like a straight line problem. The locus of moving end they will give. See here corner on ground, and instead of giving lamina inclination, they say the top corner is 30 mm above HP. What you have to do? You have to draw the locus, then take the front view length, cut an arc. Then you get automatically the inclination. Similarly, if it is edge condition also true. The top edge is 25 mm above HP. They don't give inclination. So first position. In second position, what you do? You have to fix BC, then fix the locus, then take the first front view length, cut an arc. Definitely you will get this position, inclination you will get. So there are different type of problems in corner condition as well as edge condition. Now let us work out one problem. Before that, let me conclude. For all even number of sides, the diagonal must be parallel to VP for corner condition. For odd number of sides, median or perpendicular bisector must be parallel to VP. Or for odd number of sides, the opposite side must be perpendicular to VP. Okay, opposite side must be perpendicular to VP. Automatically, this is mutually perpendicular to each other. If this is perpendicular to VP, this is parallel. So similarly, for pentagon also same thing. See, here corner on ground, I will keep it like this. So opposite side is must be perpendicular to VP initially. Automatically, this perpendicular bisector will be mutually perpendicular to these two. Definitely, this is parallel. So for all odd number of sides, either median or perpendicular bisectors must be parallel. For even number of sides, the diagonals passing through the corner must be parallel. So this is how we can continue with the problem. Now I will take two problems. One, true length and true inclination, simple problem as we discussed earlier in different problems, and then beta angle, that is apparent angle you have to consider. Now take this problem. A triangular lamina of 40 mm sides has a corner on HP. The lamina is inclined at 30 degree to HP. But carefully take the data 30 degree to HP. Next, he says the top edge is inclined at 45 degree to VP. He says right now the top edge is perpendicular to VP. First position, second position. First position also it is perpendicular. In second position also it is perpendicular. Now what we want to do is you have to take this edge inclined at 30 degree to VP, either towards observer or away from observer. Normally we take away from observer, or you can take towards observer. If you take towards observer, naturally the space management is easy. Okay. Now first, as per accordingly whatever they want, if it demands, then you do accordingly. Otherwise by default you take towards VP. First position, second position, third position. I will repeat. First position, corner condition, you see that in a perpendicular line the corner should be placed here, and then see that this median is parallel to VP, or the opposite side is perpendicular to VP. How you start working? You should start from this. Easy. Start with a side which is perpendicular to VP, to the right side. Normally you take for all laminae, unless it is otherwise specified, the item to be placed on HP, whether it is corner or ground, to the left only. Now what I do is I take the edge which is perpendicular to VP, right side, and then create this figure. Naturally you will get this two equally inclined to this line. Okay, and if you tilt it, definitely you will get equal inclination with HP, with those two sides passing through the corner on HP. Now I will start working this problem. Now actually this is, since it is inclined to HP, we will make it parallel to HP or keep it on HP. So top view is the true shape. You have to start from top view. From where you have to start? You have to start from top. Now let me start working this problem. as I said, instead of starting from corner, start from this pentagon and triangle and all, you must keep it like this. Then assume that I have created, you know how to create the triangle. I will show you how to create in the computer, but in this manually, you measure 30 mm or 40 mm, whatever given, and then take the same distance equal to radius, draw two arcs. Definitely you will get the corner. Now see this, I am keeping this. So straight away you can draw dark lines. Okay. Okay, this is triangle of 40 mm sides. So dimension it. mm. A, B, C, D. Now, this is A projected onto XY line, name it as A dash, B dash and C dash. C is not visible in front view. Next comes the front view. So, this particular portion represents front view dimension. I mean, dark it. So, this gets you the front view of the lamina, okay, which is placed on ground such that one of the side is perpendicular to VP. Next, you have to give inclination to VP HP by 45 degree, 30 degree. Yes, 30 degree is given. 30 degree. First position, second position. So if you give inclination to the front view of the first figure, then definitely you will get the inclination to HP. Now let me draw a line inclined at 30 degree to HP. First draw manually, you have to do like this. Draw a thin line, then take this into compass and then draw. In case of square and other things, with the standard position, you can take directly. But here you have to take compass and work. In computer, move and rotate. Now I am keeping the front view A dash, B dash, C dash inclined at given angle 30 degree. So dark this portion. Yes. Next, project it. How to project? You should not unnecessarily draw a number of lines. See, I always say, insist on this. Right extreme projection, the bottommost projection. Keep it so that unnecessary lines can be avoided. Now, A is this. Draw it. As usual in computer, alignment indicator is there. Easily you can do it. Now, here is C. This is automatically you get B here. This is C. This one is A. Join these three to get the top view in second figure. This, when it is inclined to HP by 30 degree, this is the top view. Right now, which is the top edge? They are opposite edge. Same thing. Sometimes the question may be the side opposite to the corner on HP is inclined at some degree. Right now it is perpendicular. It's perpendicular right now. Now after that you can keep this inclined. Now I will show you the model. First position, second position. In first position also the top edge you are going to get as BC, that is perpendicular. In this case also it is perpendicular and parallel to HP, that is most important. It cannot be like this. So how you are getting it? If you are maintaining AM, that is median parallel, definitely you will get this perpendicular and also parallel to HP. So definitely this particular condition is very important. See, BC is the important thing for us. So this becomes your top edge. Actually capital BC is the actual and top edge, and top view of that BC is small bc and this is B dash C dash in front. It is like, it looks like a point. Okay. Next, you have to do this job. The top edge is inclined at 45 degree. Top edge is this BC. You give inclination to that. So it's easy for you if you rotate in this way so that it will take towards XY. Normally by default you do that 45 degree to XY line. Draw 45 degree line and then redraw this. Take this distance, you know very well it is 40. Yes. Then you should not take this distance. This is a 40 is actual. It is on VP. Sorry, on HP. It is the apparent length you should take. These two both are equal. From C and B as centers, draw two arcs with the same radius, you get A. This is apparent shape. So you draw, join those two and get the required figure. Yes, this is the final top view. Now, when the lamina inclined to HP, when a corner on ground by 30 degree, this is the top view, and same top view is redrawn. Second figure top view is to be redrawn with BC as reference. What is BC here? Top edge at the same time it is true length. True length on true inclination. On true inclination. This is inclination only to VP is given. Then project A onto XY line because it is on HP, and project BC from previous front view and project it like this. Then this becomes where B dash, this is C dash. Join these three in order, definitely you will get finally. Just observe here, this is the top edge BC which is parallel to HP, and inclined at 45 degree to VP. So this is VP, this is HP. Just refer parallel to HP, inclined to VP. Whatever you do here, that is for VP, and whatever you do here, that is for HP. Parallel to HP and inclined to VP. So I am repeating. See, by looking at the problem figure, you must be in position to write the question. Then you will understand better. Okay. So this is how you can work out a problem on triangle. Same type, only shape changes. The method remains same, whether it may be square or pentagon or hexagon. Only thing is, for odd number of sides, it is bisector, perpendicular bisector or the median. In case of even number of sides, diagonal passing through that. We will work out that in the computer. Now, I will take second problem. It is very important. It is also important. Based on this, we will work this. Now, a triangular lamina of 40 mm sides has a corner on HP such that the surface of the lamina is inclined at 30 degree to VP. The median passing through the corner on HP is inclined at 45 degree to VP. Draw the projections. Now, the thing is here up to second figure same thing, no change because of this 30 degree to VP. The lamina inclined at surface of the lamina is inclined at, sorry, there is a small change. The lamina is inclined 30 degree to HP. Yes, same problem, 30 degree to HP, and median passing through the corner on HP is inclined at 45 degree. If there is small correction, please. Okay, this is HP. Same problem I am using up to second figure. Okay. Now, what you do? Let us take only the first part of it. Triangular lamina 40 mm side as a corner on HP and says that the surface of the lamina is inclined 30. Same thing here up to this. Now, how to change this? Okay. Now, I will see that let it be there. Assume that this is not available with us. This particular figure is not available with us. I am utilizing the same thing. XY. Up to this same. Next comes this. The median passing through the corner HP is that. Now see here, the median is AM. Median is AM. Instead of BC, top edge, he has given the reference AM. Okay. Now how to do it? First position, as usual. Second position. On what basis I have taken? I have not considered BC. I have considered AM. Okay. Now, the lamina inclined at some degree to HP as usual. We have to rotate. Now, AM is the criteria for us. AM is the reference for us for the inclination to VP. AM is already inclined to HP. Again, I am giving inclination to VP by some angle. So, a line is inclined to both the planes means you never get final projections on that particular item on true inclinations. You will get on apparent inclination as per the straight line problems. Now, I will review the straight line problem for you. Assume that there is a problem on this one. This is, let me name that as AM. It is already inclined at 45 degree to HP. Again, the AM is somewhere here. Let me correlate this with A dash, M dash. AM is the reference. AM, let me name this as M. This is M1, M. This is true length, this is apparent length. True length, apparent length. Now, this true length has become apparent length in second figure top view. I have to give inclination to this. If you give inclination to this, you must keep it on apparent inclination. How to find? So, as per the straight line concept, this is how we have to do it. AM is the true length and corresponding apparent length we have. Again, the same length is inclined at some degree to VP. See, this is inclined at 30 degree to, this is 30 degree to VP. Now, this is inclined at 45 degree to VP. Same length. This is 45 degree. This is phi. This one is theta. This is phi. Now, take this as M2, project it and rotate. This is M dash. You project it on this locus. This is M. Now, just observe the final projections are this. This is beta. This is alpha. So, this is how you get beta, apparent angle. You need not have to do all this. Very simple. Let me concentrate on this. Say, first you mark A. Okay, A. In any direction you can keep, either leaning left or leaning right, upwards, etc. Let me take an example. AM1. AM1 is true length. This distance you take, true length, and mark here. This is true length. Okay. Next, you just observe here. This is locus of M2 and M. Okay, or M1 and M. No problem. Any suffix will work for you. Now, take this distance, apparent length, and draw an arc with the radius, then you will get this. So, this is what M. Now, this is apparent length, this is true length, this is true inclination you have taken 45 degree and mark. This gives you beta. That's what you have to do. In any apparent angle problem you have to do. When you decide this apparent angle problem, when a reference line is already inclined to HP, you are giving inclination to VP, definitely you must consider. How you decide? You see that whether the apparent length has arrived or you obtain apparent length. If true length exists, no problem. Previous case I had top edge, I took it on true inclination. Now, how to carry out this? Now I start. You can again take away from actually, you keep A nearer to it. You draw true length on true inclination. This is what? The 45 degree line you draw, true length you take because it is inclined at 45 degree to VP. Then draw a line, take apparent length, draw an arc. This is apparent length. This is M2 or M1. M2 only you can take. Normally in top you refer M2. This is M2. Then AM. This is AM. Now this is beta. Then move and rotate here. I will explain that how to keep it on computer. Okay, in computer how to do it. Now what I do is, this is very simple. See, AM is this, definitely. And you see this line, geometry, it's a matter of geometry. Through M you draw a perpendicular line. That's all. Only two jobs you have to do. Draw perpendicular to AM, take this distance, that's all. Okay, very simple. Join these two. This is how you draw it. Very simple way. Now M should be there. Normally, what I observed, people again place it on AM2 as though they have not given inclination to the edge. It's wrong. So now, after getting the top view, project A. A dash, definitely it is on HP. And there are two more points available. This is B, this is C. Project it on that. See, the first problem and second problem looks alike, but the criteria is different. First one is top edge, that is true length on true inclination. Here, this is apparent length on apparent inclination. That's why I always say TL on TI. This is AL on DI. Okay. Same type we can work with respect to square laminae and other things. In square laminae, what we have to do is, you have to keep it like this. The diagonal must be parallel to XY or VP. Then rotate about that. Sometimes they may specify ABCD is the square lamina. The lamina is placed on C particularly. Then what you do? Keep it here. Otherwise, you can start ABCD, but normally we start from this. Left extreme nearest corner A, visible points, then do. Next C, you keep it like this. Otherwise, by default, rotate like this only. So, first position, second position. In case of hexagon, see, this is A, B, C, D, then diagonal is parallel to VP, you keep, then rotate like this. Then proceed. Next, if it is pentagon, keep A like this, opposite side must be perpendicular, or this perpendicular bisector is parallel to VP, then do this. Okay, I will draw simple sketches for the corner condition of the standard laminae. This is the corner, square, this is the corner, pentagon, this is the corner, and hexagon, this is the corner. Here you just observe diagonal for square and hexagon. For pentagon and this is median, this is perpendicular bisector. That's all. You can work any problem on corner condition, and also beta if necessary. Otherwise, you check twice whether to take beta or not. Then I will work some problems. Now, the computer software, let us familiarize with different types of problems for you. So, let me take a problem on triangular lamina, which I have discussed earlier in this session. A triangular lamina of 40 mm sides has a corner on HP such that the lamina is inclined at 30 degree to HP. Draw the projections with the top edge is inclined at 45 degree to VP. Okay, now alternate version of the problem, you may get the problem in this way also. A triangular lamina 40 mm side has a corner on HP such that the lamina is inclined at 30 degree to HP. As usual, you have draw the projections when the side opposite to the corner on HP is inclined at 45 degree to VP. That means, just observe here, I have given this initial position with a 3D reference. This is the corner to be placed on HP. Okay, this is the top, this becomes top edge. Otherwise, this is also referred to as the side opposite to the corner on HP. This is the corner on HP we are going to treat as A, and BC becomes the opposite edge. Here it is BC is the opposite edge, this is A. Again, the thing is here the lamina is inclined at some degree to HP, and naturally this becomes what? The corner condition with respect to HP. See here, this corner condition, the explanation is there. I have done already number of times. Lamina inclined to HP by 30 degree and corner on HP. This is corner condition instead of side condition with respect to HP. This is corner condition with respect to HP. See, and the top edge is inclined at some degree to VP. Otherwise, the side opposite to the corner on HP is inclined 45 degree to one and the same. So, this is, you have to start from top view. So, see here I have kept the lamina on HP and ABC, small ABC is top view, the actual lamina is ABC. There itself we get the impression that is top view. This is front view. Now, that's what I have indicated here. Now, how to start? We are all familiar with this. How to draw the triangle? That is very simple. I will draw triangle here for you. Okay. I will repeat that. How to draw triangle, very easy. You can just take a line. Say for example, I am interested in 40. Okay, so here given is also 40 and enter 40 with the blue line. Then don't use mouse, that gives you some different thing. Just you put enter in the keyboard, that gives you correct thing. Next, then just draw two lines at random, any scalene triangle, any scalene triangle. Then you just observe here, you just check the angle here. This is 59, you keep it 60. Again this, keep this. This also you keep, whenever you want to do these things, you try to zoom it and work out. It's easy for you. Now again you take one more angle. Okay, that is 59. Yeah, it's coinciding. It is coming, both are coming 60. Now you keep 60. Yeah, this definitely gives you equilateral angle. Anytime triangular lamina, if you take, by default it is equilateral triangle. They need not specify. If they want, they will specify isosceles triangle and the sides, etc. Now you can check the other one also, whether it is 60. Definitely it is 60, and also dimensions also you can check. Okay, see this is 60. Dimensions also you can check. This is how you can do it. Okay. Otherwise, you can create the shapes by polygon, triangle. Let us see how it works. Polygon by center. I see here 6 is there. I will make it 3. Let's see. See, you can create easy polygon by center. You create some value. Create some value of for a given this one. Okay, and then dimension it. Whether the dimension it, you will get the required dimension. See, this is 43. I want 30. Yes. Okay, you will get for 30. So this type of calculation you can do. I mean workout you can do. So the easy thing is you can use polygon, or easy way is you create one line and then create triangle. That can be done. Whatever is you feel easier, you do it. Okay. Next comes the okay. You move and rotate. You get the, after creating this this one, you know how to create the front view. A dash B C is not visible. Then you move and then rotate by 30 degree. Then get the corners by projecting it properly without extra lines, and get the second figure top view. Till this point, for both the cases, same answer. Okay. So next you try to move and rotate. See, you have to rotate this. Already I have shown you how to rotate this. You can also do that job. You need not fix 45 first and then rotate. It's a cumbersome job. Directly you can do it. I will repeat if you want. See, how to, how to move, then how to rotate by 45 degree. I will tell you. Now you go to this, rotate. Already you have fixed. Then you rotate this CB or VC by 45 degree. Since it is 45 degree, it is easy. Vertical as well as horizontal, you will get same value. Now you check. Directly you can rotate. You need not fix first. See, 45 degree you got. You can dimension like this. Okay. There is no necessity of drawing a particular line and then place it on that. It needs to waste of time. But also you have the facility, you can do directly. Now, after doing this job, now I am very specific. BC is true length. The first figure top 40, the second figure top. Since it is on HP, I mean parallel to HP, definitely it is parallel and true length. True length and true inclination. There is no question of beta. Okay, see here you can observe BC is parallel to HP and inclined only to VP. Inclined to VP, parallel to HP. So you can, at any moment you can check. See, this top edge is parallel to HP, inclined to VP. This is how you get the final solution for this problem. Now, here the median passing through the corner HP is inclined at 45 degree to VP. Same thing I have worked out how to work. Lamina is inclined to HP by 30, corner on HP, then corner condition with respect to HP. Start from top view because lamina inclined to HP by 30 degree. Okay. Now, same position, corner condition, you see that the median is perpendicular. If you draw median, now let me see. This itself works for you, BC, that median is parallel to, okay, VP. Median right now is parallel to VP. Let me name this as M, M2 or M1, etc. Anything you can work. Otherwise, without naming also you can do. It is only for understanding purpose. This is M2 or M1, no problem. Now see, I have kept M1, M1. After you get this, it is very similar to the first problem which I worked out. Now here I have given the median AM is inclined to both HP and VP, then that means AM is in second figure top view is apparent length, hence find beta. So AM1 is true length, AM is apparent length. How to do it? See, these are the various directions you can take. See, first position is you take true length and true inclination. In general I have taken, it works for all problems, not necessarily AM and AN. PQ is true length, PR is apparent length. This is the procedure to find whether it is beta or alpha. In case of HP area, you have to keep a beta. In case of VP area, same problem will come. You have to take true length first, then draw the locus, then draw apparent length, then find out alpha. Okay. So this is otherwise it is phi beta. Anything. This is with respect to VP area, this is with respect to HP area. Now in this particular problem, we can have any orientation. In this case, I have suggested you to do this orientation because I have taken A here, M1M. So any orientation you can take and do it for any, whether it's VP area or HP area. That's why some people ask me whether you take only this way. Anywhere you can, even you can keep outside and do it, but not outside the sheet. The answer should contain this particular anywhere separately. Then say beta equal to so much and directly take. You need not show the procedure there itself. But normally we do this. Now I have let me come to the actual problem and discuss. I have drawn the true length with 34.64 as the true length AM1. Okay. Now I have drawn the locus through that. Then I took this AM apparent length and drawn an arc with 30 mm. This has come 30 mm apparent length. Now I have joined this. Now how to do it? Especially this is a small one, and then you say how to, with all these figures, how to do it. Now I will show you how to do it. You have to bring it like this. How to bring it I will show you. Now you take this, move. This is the efficient way of doing it. Let me avoid dimensions. See, A only you pick. You click on A, end point you have. You bring up to A, end point. Click there. That's all. Okay. Anyway, you have to do that shadow. Hit in there also. I will repeat. You take, move and make this dark so that move copy. Okay. Now you take end point of the any line and then keep up on A, again end point. Then see, there are two A's and two M's you come once you do it. Then you remove A and M. Okay, otherwise you can retain. But better you remove it. Now after this, you rotate. Okay, how to rotate? See, once you start rotating, if you select, all will come. Even AM line will come to you. So what you do is extend this line to retain that line so that you can rotate up to that. So I will do that job again here. Here I will do it. Now, if you rotate this, if you select this, the AM also will be selected sometime. Otherwise, how to avoid that I will tell you. Now, you just observe, rotate, you avoid this slightly, you keep this and then do it. Yeah, you have retained. Otherwise, what you do is you keep M as the reference. So M as the reference and then rotate. Again you connect with M. Okay, that also you can do. for efficient way of working. If you select like this, all will select, everything will move. I will show that. So if you select like this, where to stop you may not know. See, everything will do. See, here you can stop here. I think this is an improved version of this. You can do it, but you may not know where exactly. If you select M as a reference, then you can do it. Now, let me do that job. Rotate exactly this end of the line. Then M, particularly M you take. Then you keep it on M. Yes, this is how you rotate. Then project and get the final front view. So this is what I have done for you. Move and rotate, then project, get this. Yeah. So this is final solution for this problem, beta problem. Beta equal to 50. But specify this. Otherwise, you can keep this figure outside somewhere here and then do it. And directly take 55 degrees and draw it, and then you say to find beta here, somewhere here. You can keep this figure, one of the figure. Okay, I have shown you somewhere. Okay. You can keep this figure somewhere. Okay, and do it. Now, this is what the beta problem. Okay, many times if people confuse when to take beta. Suppose that if they say appears to be, see here I have given a statement, appears to be inclined at 45 degrees. I added this statement, word appears to be. In that case, beta is given. So it looks like that finally. The actual value will be less. Let us not worry. Whatever he has given, you take. So that means up to second figure it is same thing. Up to second figure it is same. Only from third figure onwards it works. It changes. Okay, I have to take directly the value given. See, first figure, second figure, everything is same. Third figure, you have to rotate with respect to the given value. That's all. Whatever appears to be means he has given. So top view of the median inclined at 45 degree to XY, you will address to XY, never address to VP. So top view must be addressed to, top view priority must be addressed to XY. So here he says instead of this, the median passing to the corner HP appears to be inclined 45 degree to VP, or the top view of the median passing to the corner HP is inclined at 45 degree to XY, they will give. So in that case also beta is given. Okay. Now as usual you complete the problem. You take it directly on this 45, beta equal to 45, then complete the problem. Okay. So next comes the side opposite to the corner HP is inclined at some degree to HP. Okay. Yeah. The lamina is inclined to VP. Okay. So what you should do is to start from front view. Okay. Then I cannot say top edge. I could say the side opposite to the corner HP, corner on VP is inclined 30 degree to HP. Everything is reverse. It is reverse problem. Okay. First problem is the lamina on HP. Now it's lamina on VP. Corner on HP. Here corner on VP. The opposite side is same problem. Okay. It is dealt with same type of thing. See, the median or the perpendicular bisector or diagonal must be parallel to XY line in this case also. This is corner condition with respect to VP. See, here this is corner condition with respect to, see what he says, lamina inclined to VP by 45 degree, make the lamina parallel to VP or place it on VP to get true shape on VP. That is, true shape is front view, hence start from front view. So the side opposite to the corner to be placed on VP is always perpendicular to HP in first figure front view. Okay, that's what I have given. I have not touched the median because it gets confused. That is only for the beta angle problem I can do. Now start with the front view with corner and opposite side perpendicular to XY line. Then get the top view, move to a particular position and then give inclination. Then try to get the corners by projecting it, get the second figure top view. Now, which is the side opposite to the corner on VP? Here, B dash C dash is the projection. Actually, it is BC. BC is the opposite side. This must be inclined at some degree to HP. Okay. So, whatever you do here, that is for HP. Here, it is perpendicular to HP. Again, it is perpendicular to HP. I have to maintain some inclination to HP. 30 degree. He has given 30 degree. What you do is, you move and rotate, move and then rotate this such that BC is 30 degree. Again it is true length. See, this is 30, 40, this is also 40, this is also 40. No change because it is on VP. On VP inclined only to HP. So 30 degree is true length and true inclination since B dash C dash is true length. Now project it and get final figure. So this is how you get the projection of planes for a given particular position. Now let me take same problem for square instead of triangle. Just observe here a square lamina of 40 mm sides as a corner on HP. The surface of the lamina is inclined at 45 degree to HP. The diagonal passing through the corner HP is inclined at 30 degree to VP. See, in this case, instead of giving the surface inclination, you could have given directly the diagonal passing through the corner HP is inclined at 45 degree to HP and 30 degree to VP. So, if lamina inclined at some degree to HP, the diagonal also assumes same angle. Otherwise, diagonal inclined at some degree to HP, surface also assumes same angle. See here, you have to do this job, same corner condition, diagonal parallel to VP you have to create. How to create I will tell you. Now, the problem is if you move it and then incline, how to get BD point? In this particular case, this is characteristic feature of square with 45 degree inclination, you will get midpoint as the BD. Okay, that's what I did here, midpoint. But once you start projecting, it creates problem. That's why I have already made some line here. See, for clarity, I have made one line. What you do is, you take the line command, and from this you draw a perpendicular line, very thin line, 0.13. Then that gets you some idea. Otherwise, midpoint you can use it and then project as BC. But some indication must be there. That's why I have made one line. Okay. So, the thing is here, corner condition is the reference diagonal parallel to VP. Next comes move and rotate 45 degrees. He has given surface inclination is 45 degree to HP. Then project it, get the points. Unnecessary lines you avoid by use alignment indicator. For example, I will remove these two and then tell you how to do it. Okay, alignment indicator how to use. See, this you take the line command, thin line, 0.13, and see, you catch this, see, and then mark point, see, dotted line will come. Yes, go up again. Automatically you will get all points you can do. But if you keep this line, that works for 2 points, B and D directly. First you do this, B, then automatically you will get up to this point, you get D. So that is how you can optimize your method in time. Now you get the, now what happens, AC, capital AC is the actual diagonal is inclined to both HP and VP. See, it is again the diagonal passing through the corner HP is inclined at 30 degree to VP. Again, already it is inclined at 45 degree to HP. As I explained, when a straight line is inclined at some degree to both HP and VP, you will get beta or alpha as the reference. Now, AC, assume that AC is a straight line, it is already inclined to HP by 45 degree. Again, it is asked for 30 degree inclination. So, what you do is, you find out beta. See how to find beta? I have given the explanation already. Take true length, that is equal to 56.57, and then take apparent length 40 exact, draw north, okay, on a locus, you get C1 or C2C, anything. Now, this one is the final one. On that, as I explained in the triangle problem, you move and rotate. That's all. Then project it, get the final printing. So, this is how you get, this is the final solution for this particular problem. Now, just say the corner is on HP, A dash, and AC is the diagonal, the lamina is inclined 45 degree, AC itself is inclined at 45 degree. Once lamina assumes 45 degree, AC also, okay. But sometimes what happens is, the question itself is the lamina as a corner on HP, and draw the projections and the diagonal passing the corner HP is inclined at 45 degree to HP and 30 degree to HP. Both they will merge there only. Definitely same answer. Okay. Next, if he says appears to be, instead of directly giving the inclination to Vp, if he adds this appears to be, then you take the beta is given. See, beta, whatever the B value is given, you take appears to be inclined, beta value is given. You move and rotate this second figure top view, redraw second figure top view so that beta equal to 30-degree line, on 30-degree line. So now you get the final solution for this. Appears to be. Suppose sometimes he says appears to be perpendicular to Vp. What is perpendicular? 90-degree. So appears to be perpendicular to Vp. So beta equal to 90-degree. In that case, you move and rotate such that AC is 90-degree. Accordingly, you get the final top view and front view. This is final solution for appears to be inclined at, appears to be perpendicular to Vp or 90-degree. So this is a specific condition. How, when you get this condition, when theta and phi, inclination with respect to HP and Vp for a straight line reference, is equal to 90, then definitely you will get the value. See, a square lamina as corner on HP, the diagonal passing through the corner HP is inclined 50-degree to HP and 40. This can be a combination of 60-30 or 30-60, 50-40 or 40-50, anything. Total inclination is 90-degree means beta equal to 90-degree. This is a typical case where people get confused. See how you get this. Now what I have done, same thing, 50-degree to HP and 40-degree to Vp. 40-degree inclination I have done. I have taken true length, yes, 56.57 as usual with the previous problem. Now this is apparent length, I got 36.36. I have drawn north. It is just like tangent. See, this arc and this line is a tangent to this. Definitely it's interesting. If you do small mistake, you never get this. It will be above or below. Okay, you will get some value, inclination less than 90 or more than 90. You never get exact. So we must do it carefully. Then create. See, this is how you do it. True length and true inclination, this 56.7, and this one you get straight, that is 90-degree. Beta equal to 90. Then you redraw it and then get the final solution. So this is how you get solutions on corner condition with beta and without beta. So in further we will discuss the problems on pentagon, hexagon with varied criteria or data. Okay.